Hello math students, today's video is lesson 3.6 graphing all polys. This is very similar to what we did in 3.5 scene structure with graphing polynomials. We are going to start with this graph. I want to write everything that I know about this polynomial, including the roots, which is just really the same thing as the x-intercepts, end behavior, and y-intercept. So like I said, the roots and the y or the x-intercepts are pretty much the same thing. So this has three separate roots. I have one x equals -3, x equals -1, and x equals 2. All of these are going to have a multiplicity of 1 because it just crosses right through the x-axis. Because it has a multiplicity of 1, I don't necessarily have to write down the multiplicity, but I still am going to anyways. For the end behavior, I'm just going to look at the graph. I'm going to see as I go to the right, my graph goes down, left, it goes up. So I'm going to write as x approaches positive infinity or goes to the right, f of x approaches negative infinity or goes down. And then as x approaches negative infinity, f of x approaches positive infinity or goes up. Another way I could write that is I could say that it's down to the right and then up to the left. The y-intercept we see from the graph is just at 6. And then if I wanted to write out the equation, first off, an equation always has to have an equal sign. Otherwise, it's not an equation, it's just an expression. So I'm going to have my 3 factors because I had 3 x-intercepts. When I'm giving you an equation, I want you to find the x-intercepts. We change the sign to get the x-intercepts. So when I put it back in the parentheses, instead of being x minus 3, it's going to be x plus 3 because I want to solve the equation. I'm trying to get -3 as the answer. If I have x plus 3 equals 0, subtract 3 from both sides gives me -3. I also, for the same reason, I'm going to have x plus 1 and then also x minus 2. This is almost my equation. However, because I was going down on the right side, I have to have a negative leading coefficient. If I want to look and see whether it's going to be positive or negative, let's look and see what is f of 0 equal to. So f of 0, based on what I have right now, is -0 plus 3 times 0 plus 1 times 0 minus 2. If I go and simplify that, that's -3 plus 1, or times 1 times -2. Multiply it all out, it gives me a 6, which is the same as my y-intercept. So this is my equation. The next thing I want to talk about is what is called the remainder theorem, which is basically what we already know. It's nothing new. The remainder theorem says that if f of a equals 0, so if I plug 0 in for x, or a in for x, and I get a 0, that means x equals a as a factor. We've really kind of been going the other way, where if I have a factor and then I know x equals a as a root. So saying f of a equals 0, that's just saying x equals a is a root. This next part is just going the opposite direction. So it's what we really already know. If I have some polynomial in factored form, that means that R1, R2, and R3 are going to be roots. On the 3.6 homework, there are 4 questions that give you a polynomial and ask if a given number is a root. What you're going to want to do is you're going to want to plug that number in for x. So I'd go f of 1 equals 1 cubed plus 5 times 1 squared plus 2 times 1 minus 8, and then simplify this. All of the 1's really just become 1, so I have 1 plus 5 times 1 plus 2 times 1 minus 8. 1 plus 5 is 7, or 6, plus 2 is 8, minus 8 equals 0. So that means that x equals 1 is a root. For these last 3 examples, I am giving you the roots and the leading coefficient, and I want you to find or write a polynomial equation. After we've done that, I want you to get the y-intercept and end behavior, like we did in 3.5, in order to sketch a graph of the function. So I have these 3 roots, 3, -2, and 0. That means that my equation, once again, make sure equations are always f of x, is x minus 3 times x minus -2 times x minus 0. But then I have a leading coefficient of -1. I can also rewrite this x minus 0 that I have over here at the end is just an x. I'm going to bring that down to the front and say this is -x times x minus 3 times x plus 2. So that's my equation. To find the y-intercept, I just want f of 0, which is -0 times 0 minus 3 times 0 plus 2, which simplifies to give me a 0. And then for the end behavior, I'm going to see what is my degree, and then I already tell you the leading coefficient is -1. So degree, there's a couple different ways that I get this. I can either look and see what's my biggest exponent when I'm in standard form. So I have 3 x's, which means my degree has to be 3. Or if I look and see how many roots do I have. The number of roots is the same as the degree. So there's 3 roots, which means it's degree 3. For my end behavior, I'd say as x approaches positive infinity or goes to the right, f of x approaches positive infinity. As x approaches negative infinity or goes to the left, f of x, and actually on the right, it's going to approach negative infinity because my leading coefficient is -1, and because I have an odd degree, left and right go opposite directions. So let's go ahead and put this all on the graph. So I have my x-intercepts. I've got a -2, +3, and 0. And then my y-intercept is my x-intercept. As I go to the right, my graph is going to go down because of my negative leading coefficient. Left, it's going up because of my odd degree. And then all of my roots had multiplicity 1. So I'm going to come from the top, go through my x-intercept, change directions, go through my other x-intercepts, and then go down. And that is approximately what this graph is going to look like. Same kind of thing on number 3. When I'm writing the equation, once again, make sure you do f of x. I have a leading coefficient of 1, then x minus 5 times x plus 2, so we're always going to change the sign, x minus 1. Or if you don't want to, you don't have to write out that 1 right there. Y-intercept, plug 0 in for x. F of 0 equals 0 minus 5 times 0 plus 2 times 0 minus 1, which is -5 times 2 times -1, which is 10. For the end behavior, I tell you the leading coefficient, is a positive 1. And the degree, because I have 3 roots, is 3. So as x approaches positive infinity, that leading coefficient causes me to go up or approach positive infinity. As x approaches negative infinity, my odd degree means left and right go opposite directions. So when I put all of this on the graph, I have my x-intercepts at 5, -2, and 1. For the end behaviors, I go to the right, it's going up, left is going down. All my roots have a multiplicity of 1. So I come from the bottom, go up through my y-intercept, which is a 10. Come back down through my x-intercept, change directions to go through my last x-intercept. And that is more or less what my graph looks like. As we're graphing these, I want you to realize that what we're putting on the graph is not necessarily exactly what it looks like. These maximum and minimum points, the high and low points, may actually go higher or may actually go lower. I don't really care. All that I care about is that your x-intercepts are in the correct location, the y-intercept is in the correct location, and you have the correct end behavior. As long as those 3 are correct, then that's all I care about. Our final example is a little bit different because I have these 2 roots that are the same. That means that x equals 1 has a multiplicity of 2. So when I write my equation, I can either write out the x minus 1 twice, or I can write it as x minus 1 squared. And then make sure I change the sign for the other roots. One other thing to not forget is my leading coefficient. That just means I have a negative out front. For the y-intercept, we're going to look and see, well, f of 0 is negative 0 minus 1 squared times 0 plus 4 times 0 minus 2. The zeros don't really do anything, so this is negative 1 squared times 4 times negative 2. The negative 1 squared becomes positive, so when I multiply everything out, it becomes a positive 8. For the end behavior, my degree here is going to be a 4, and my leading coefficient, I told you, was a negative 1. So it means as my x approaches positive infinity or moves to the right, f of x has to become more negative, has to go down. And then as x goes to the left, that even degree means left and right go the same direction. So it's also going to go down. So let's go ahead and put everything on my graph. I have x-intercepts. We had that root with multiplicity of 2 at 1. I have 1 at negative 4 and positive 2. For the end behavior, as my graph goes to the right, it goes down. As I go to the left, it goes down. And then I also had my y-intercept at 8. So when I graph this, I come from the bottom, I go through my x-intercept, come up, go down through my y-intercept. At x equals 1, because I had multiplicity 2, I touch but don't cross through. And then I need to make sure at 2 that had a multiplicity of 1, so I just cross through. And then once again, all that I care about when you are graphing these is that your x-intercepts with their multiplicities are the same. That they're correct. Your y-intercept is correct, and the end behavior is correct. That is all that I am looking for on these.